There seems to be an unspoken rule in nature. Life in the ocean is almost always more terrifying than life on land. This holds true today and has been the case throughout much of Earth's history. Even during the age of the dinosaurs, an era already filled with fearsome predators like T-Rex and Dromaeosaurs, the oceans harbored creatures so monstrous they could give you more nightmares than anything stalking the land. In fact, it's surprisingly difficult to find a time in Earth's past when the sea was less dangerous than the land. But there was a brief period, long before the dinosaurs appeared, when your odds of survival were actually better in the water. During this narrow window, the surface world was so harsh, unpredictable, and hostile that the ocean, usually the realm of nightmares, was the safer place to be. This was the Lopingian. The name might not mean much at first glance, but it marks the final epoch of the Permian period, a time that unfolded between roughly 259 and 252 million years ago. It was one of the most alien chapters in Earth's history, a period when even time and geography were vastly different from what we know today. Back then, the moon orbited closer to Earth, which caused days to be shorter, around 22 hours instead of 24. As if that wasn't strange enough, the land itself was almost unrecognizable. Nearly all of Earth's land masses were fused together into the giant supercontinent known as Pangaea. This massive landform united what we now call Africa, the Americas, Antarctica, India, Australia, and large parts of Europe into a single connected body. To the east, some land managed to escape Pangaea's grasp. The largest of these islands consisted of what we now know as Siberia, Kazakhstan, and northern China. South of that lay another separate landmass, made up of South China and parts of Southeast Asia. Even modern regions like Turkey, Iran, and Tibet existed as isolated islands, bordered by two significant bodies of water, the Tethys Ocean to the west and the Paleotethys to the east. While those oceans were vast in their own right, they paled in comparison to what lay to the west of Pangaea, Panthalassa. This enormous, prehistoric ocean was unlike anything before or since. It covered more than 60% of Earth's surface, making it far larger than today's Pacific Ocean. It wasn't just a sea, it was a world unto itself. Imagine an ocean twice the size of today's Pacific. That alone is enough to stir anxiety. It sounds like a place you'd want to avoid at all costs. But surprisingly, despite Panthalassa's sheer size and that of the surrounding seas, the marine life during the Lopinian wasn't nearly as terrifying as you might expect. Sharks had already been around for over 200 million years by this point, so it's no surprise they were part of the ecosystem. If you're a Permian enthusiast, you might be thinking of Helicoprion, an 8-meter, 26-foot-long, shark-like fish famous for its bizarre spiraled tooth whorl on the lower jaw, one of the strangest dental structures in Earth's history. This creature has become something of a poster child for Permian marine life. However, by the time of the Lopinian, Helicoprion had already gone extinct. That doesn't mean sharks were absent. Far from it. There were still relatives of Helicoprions swimming the seas, though none reached such monstrous sizes. The largest among them, like Hibbertopterus and species from the genus Hybotis, rarely exceeded 2 meters, around 6.5 feet, about the length of a modern leopard shark. These sharks weren't especially fearsome either. Their teeth were adapted for soft-bodied prey like squid, not bony fish or hard-shelled animals. Other groups, like the sphenacanthids and hybodonts, were even smaller. typically no more than 1 meter, 3.3 feet in length. In general, these sharks were diverse but modest in size and not especially threatening. It's ironic. In a time when land was a brutal, unforgiving environment, the oceans, vast as they were, remained relatively subdued. There were, however, a few oddities and holdovers from earlier eras, still lurking beneath the waves. A group of now extinct arthropods, once giants of the ocean, were still clinging to existence during this time, but they were far from thriving. These were the Eurypterids, or sea scorpions, and though they had once been highly diverse and enormous during the Devonian period, their fortunes had drastically changed. By the Lopingian, they had never fully recovered from the Devonian extinction event. Only 2 genera are known from this era, and neither were large nor dominant predators. Their decline was part of a broader pattern. Nearly every major marine group was struggling. Much of this can be traced back to the Capetanian mass extinction, which occurred just 2 million years earlier. Though not widely known, the Capetanian extinction was actually deadlier than the more famous Cretaceous-Paleogene (KT extinction) and the Triassic-Jurassic event. Its impact was felt across the globe, but marine ecosystems suffered the most. As a result, during the Lopingian, the oceans were home to a dwindling and weakened population of creatures like trilobites, ammonoids, and brachiopods. They were still around, but barely, and none were particularly large or numerous. Things would only get worse for marine life after this period, but we'll return to that later. For now, it's important to realize just how subdued life in the water had become. The oceans of the Late Permian may sound dull, but this was actually a key point in Earth's history, and one to be oddly thankful for. Because while the seas may have been quiet, the land was anything but. The Capetanian extinction had devastated terrestrial life as well, but the recovery on land was quicker and far more dramatic. The event cleared out many of the Earth's former dominant species, paving the way for new, more dangerous creatures to take their place. Unlike in the oceans, life on land didn't just recover, it came back with teeth. The Inostrancevalians had once dominated the land, large-bodied, highly successful therapsids that flourished throughout much of the early and middle Permian. But despite their earlier triumphs, they failed to survive into the Late Permian. Their disappearance left a power vacuum on land, opening the door for new groups to rise to prominence. Among the many contenders that emerged, one group in particular would take full advantage of this opportunity, much to the misfortune of everything else that walked the earth. These were the gorgonopsids, Earth's original saber-toothed predators. Discovered by paleontologists in 1876, the remains of these ancient beasts were so terrifying that they were named after the Gorgons of Greek mythology, and with good reason. Gorgonopsids, while varied in size and form, shared a set of fearsome traits: deep-set, blade-like teeth, long, narrow skulls, parasagittal upright gait, and most notably, enlarged saber-like incisors and canines. These adaptations made them some of the earliest saber-toothed predators in Earth's history, millions of years before saber-toothed cats like Smilodon ever appeared. Despite their feline appearance, gorgonopsids were not cats. In fact, they weren't even mammals. Like the Dinocephalians before them, they were therapsids, a lineage more closely related to mammals than reptiles, but still not true mammals themselves. Gorgonopsids first appeared around 265 million years ago, during the Middle Permian. Early species were small, no larger than a human foot, and hunted insects and tiny reptiles. But as time went on, and as competition fell away, the gorgonopsids began to grow. This trend accelerated dramatically in the late Permian, after the extinction of the Dinocephalians cleared the playing field. Eventually, this evolutionary arms race produced the largest gorgonopsid of them all, Inostrancevia. This predator wasn't just the biggest of its kind, it was the apex land predator of the late Permian. Fossil evidence suggests that fully grown adults could reach over 11 feet, 3.5 meters in length, and weigh more than 1,000 pounds, 453 kilograms, comparable to a modern-day bear. More commonly, individuals were closer in size to a large tiger. What set Inostrancevia apart wasn't just its size, but its build. Unlike its more gracile relatives, it had strong, robust limbs that gave it a powerful, sturdy frame, making it surprisingly fast and double. On the brutal Permian landscape, this saber-toothed killer was the top of the food chain, and anything smaller was fair game. A wide range of medium to large-bodied herbivores roamed the earth during the late Permian, but once they were caught, their fate was grim. If unlucky enough to be targeted by Inostrancevia, they were in for an especially brutal end. This apex predator was armed with some of the most formidable teeth ever seen in non-mammalian therapsids. Its upper canines measured an astonishing 15 centimeters, 6 inches in length, placing them among the largest saber-like teeth in its evolutionary class. But it wasn't just the size of these teeth that made them deadly. They were also curved and serrated, allowing Inostrancevia to slice cleanly through flesh, triggering massive blood loss and catastrophic internal injuries. These weren't just puncturing tools, they were precision-killing instruments. Despite their clear lethality, paleontologists still debate how exactly Inostrancevia used its deadly arsenal. One theory likens its hunting strategy to that of Smilodon, striking at the throat or neck for a swift kill. Another proposes a more methodical approach, biting and retreating, allowing blood loss and shock to wear down the prey over time. Either way, it was an agonizing death. Meeting Inostrancevia was something no animal, and certainly no time traveler, would have wanted. Complicating matters for other species was the fact that Inostrancevia wasn't confined to a single area. It had a surprisingly wide geographic range, with fossils found in what is now Africa, Asia, and European Russia. This saber-toothed predator also appears to have been highly adaptable, thriving in vastly different environments, from the warm, lush floodplains of South Africa to the cold, arid deserts of Permian Russia. In these harsh northern environments, relief came only from occasional shallow lakes and sparse forests, dominated by Glossopteris and other seed ferns like Peltospermum, which defined the flora of the time. Because Inostrancevia lived in these colder regions, some paleontologists speculate that it may have had fur to help regulate its body temperature. But so far, no direct evidence has confirmed this. As terrifying as one giant gorgonopsid might be, the late Permian was home to far more than just Inostrancevia. In fact, dozens of gorgonopsid species are known from this period, especially in the region that is now European Russia. These included smaller species like Pravoslavlevia and medium-sized predators such as Suchogorgon. This proliferation meant that gorgonopsids held absolute dominance over many ecosystems, acting as the primary predator regardless of herbivore size. As a result, Permian Russia was not a place you'd want to visit, unless you had a death wish. But even Russia couldn't compare to the nightmarish predator scene of late Permian South Africa. There, a whole subfamily of gorgonopsids evolved independently alongside Inostrancevia, the Rubidgeas. While Inostrancevia remains the largest individual gorgonopsid ever discovered, the Rubidgeas were, on average, the largest group overall. These predators were easy to identify by their thick, robust skulls, the absence of a parasphenoid bone, rapid tooth replacement, and deeply serrated teeth, likely even more efficient at slicing than those of Inostrancevia. They were also heavily built, with some species approaching Inostrancevia in size. One standout example was Rubidgea atrox, a terrifying predator that exemplified everything dangerous about this lineage. Together, Inostrancevia and the Rubidgeas made the Late Permian a golden age for saber-toothed killers and a deadly era for anything unlucky enough to be on the menu. One particularly fearsome species of gorgonopsid roamed what is now South Africa and Tanzania. Known for occasionally reaching lengths of up to 10 feet, 3 meters, its size alone placed it firmly in the role of apex predator. But what truly made this creature stand out and strike fear into anything sharing its territory was its skull. The skull of this gorgonopsid made up over 15% of its total body length. Fossils show that it was not only enormous, but also incredibly thick, with signs of skull bossing, bony protrusions, indicating that this predator was built for grappling with. This modest bite force highlights how deadly efficient its saber-like teeth were, designed not to crush, but to pierce through flesh and hide with ease. Much like Inostrancevia, this gorgonopsid, believed to be Rubidgea, could likely shape entire ecosystems on its own. But unfortunately for everything else, it was rarely alone. Fossil evidence suggests that Rubidgea coexisted with multiple other members of its subfamily, the Rubidgeae, which included at least 9 genera, ranging from medium to large in size. If that wasn't already bad news, it's now thought that Rubidgea also coexisted with Inostrancevia in Late Permian South Africa. Given their similar size and ecological roles, it's likely they competed for the same prey, leading to frequent and fierce conflicts. This paints a chilling picture of a time when apex predators weren't rare, but plentiful. The land truly belonged to the gorgonopsids, a terrifying age where water was, ironically, the safer option. But even beyond gorgonopsids, the Late Permian wasn't short on nightmares. Another major group of predators prowled the land during this era, the Therocephalians. These creatures, also therapsids, first emerged during the Middle Permian. While they didn't reach the same colossal sizes as the gorgonopsids, they were equally widespread and even more diverse, with fossils found across Russia, Antarctica, Africa, and China. While a few species evolved into herbivores, the vast majority were carnivorous, and many could be mistaken for gorgonopsids at a glance. However, there were key anatomical differences. Therocephalians typically had broader, deeper skulls, shorter, more compact bodies, straight, smaller teeth, a generally more muscular, robust build. Their diversity also allowed them to experiment with hunting strategies and adaptations not seen in gorgonopsids. Some, like the dog-sized Ichthyophanathus and Eucymbersia, are even hypothesized to have been venomous, which, if true, would make them the first tetrapods to evolve venom. Other Therocephalians adapted to life on the edges of water, with species like the Ichthyosuchids possibly living a semi-aquatic lifestyle. Meanwhile, fully terrestrial members took on large prey using a range of unusual tactics, including saber-like teeth in some lineages like Scutosaurus, sometimes dubbed the Silac of swords. But of all the Therocephalians, none were more formidable than Moschorhinus. About the size of a modern jaguar, Moschorhinus was an apex predator in its own right. It had an unusually large head, comparable in size to that of a lion, filled with sharp, conical teeth, ideal for seizing and holding struggling prey. The massive skull hints at a strong bite, and fossilized limb structure suggests that Moschorhinus likely subdued prey by pinning it down with powerful forelimbs before delivering fatal bites. Before delivering devastating bites with its sharp, conical teeth and powerful jaws, Moschorhinus would first pin down its prey using its muscular forelimbs. Fossil evidence reveals that this formidable predator wasn't just deadly, it was also incredibly common, ranking as one of the most abundant Therocephalians of the Late Permian. In fact, it was one of the only non-gorgonopsid predators known to reach true apex status during this time. And in some environments, it may have even displaced gorgonopsids as the top predator. Interestingly, while Moschorhinus was one of the most successful, it wasn't the largest Therocephalian. That title likely belongs to Megawhaitsia, a distant relative that prowled what is now European Russia during the first half of the Lopingian epoch. This massive carnivore grew to around 3 meters, 9 feet in length, making it the largest known Therocephalian to date. Clues about its diet come from coprolites, fossilized feces, which suggests that Megawhaitsia preyed on large dicynodonts. Even more intriguing, studies of its skull structure hint at the presence of a venom gland, along with multiple venom ducts, implying that this predator may have used venom to incapacitate its prey. If true, this would make Megawhaitsia one of the earliest known venomous tetrapods. However, due to the poor preservation of prey remains, the venom hypothesis remains a topic of debate within the paleontological community. By this point, the Late Permian should be coming across as a chaotic and deadly place, dominated by gorgonopsids and Therocephalians, with massive predators often sharing overlapping territories. But even these terrifying beasts were just the tip of the iceberg. Beyond the saber-toothed therapsids, the land was also home to a wide variety of other carnivorous creatures, each distinct in form and hunting style. Therocephalians were among the most notable. Though not closely related to crocodiles, they looked strikingly similar. Long-snouted, slender-bodied reptiles equipped with needle-like teeth ideal for catching fish or small animals. These semi-aquatic or terrestrial predators could still reach respectable sizes and were widespread, found on nearly every continent except Antarctica and North America. Then there were the Inostrancevia, another group of croc-like reptilian predators. Unlike Therocephalians, Inostrancevia had extensive bony armor along their backs, possibly serving as protection against attacks from larger therapsids. They varied widely in ecology. Some were land dwellers, others more at home in the water. Though typically no bigger than a large monitor lizard, some Russian species like Uranocentrodon could grow as large as female American alligators, making them formidable predators in their own right. And then there were the amphibians. Not like the frogs and salamanders we know today, but massive, primitive beasts that lurked in freshwater environments across Pangaea. These animals were perhaps the biggest threat near water, as many had evolved into specialized ambush predators. Lurking motionless in lakes, swamps, and rivers, they would strike at anything within reach, whether swimming or merely passing by the water's edge. Numerous families of these amphibians existed during the Late Permian, each adapted to a specific niche, and many were terrifying in their own right. They remind us that in the Late Permian world, danger didn't just come from the land or air. It also came silently from beneath the surface. The most dangerous freshwater predators of the late Permian were the rhinesuchids, a family of early tetrapods thought to be ancestors of modern amphibians. These creatures typically had 4 limbs, long tails, and bodies resembling giant salamanders or crocodilians. Among them, the most terrifying was Uranocentrodon, a 4-meter, 13-foot behemoth that lurked in South African waters, right alongside the already terrifying gorgonopsids and Therocephalians. That region, clearly, was one of the worst places to end up in the Permian world. In European Russia, things weren't much safer. There, the massive Uranocentrodon was absent, but its role as a top aquatic ambush predator was filled by the Ergosaurids, another group of large-bodied tetrapods. While more slender and narrow than rhinesuchids, they were still formidable, with some genera like Melosaurus reaching up to 3 meters, 10 feet in length. Given the sheer number of predators roaming both land and water, it's hard to imagine herbivores surviving at all. Yet they did surprisingly well and were more diverse than their carnivorous counterparts. Across much of Pangaea, large expanses were home to dicynodonts, captorinids, and periosaurs, each equipped with adaptations that helped them endure the threats around them. One of the most iconic herbivores of the time was Lystrosaurus, a stout, pig-sized dicynodont that was also one of the most abundant vertebrates of the late Permian. Though it had an odd, barrel-shaped body and tusks, it was no pushover. It possessed powerful forelimbs and likely used them to dig burrows, providing crucial protection from predators and extreme weather. Burrowing was apparently a useful survival strategy, as other groups like cynodonts also independently evolved this behavior, using their broad, flat skulls to move large amounts of dirt. On the opposite end of the defense spectrum were the periosaurs, which opted for a tank-like strategy. Instead of burrowing, they evolved heavy armor and dense bones. Many species had thick, bony plates, called scutes, embedded in their skin. Some were even adorned with spikes and other defenses. The most famous periosaur, Scutosaurus, weighed over 1.2 tons and was about as long as the largest gorgonopsids. While slow and not built for running, its tough armor and massive, muscle-dense body made it a walking fortress. Scutosaurus was only found in European Russia, but the periosaur family had a global distribution. Other notable herbivorous groups of the time included the kingoriids, oenetids, and Dinocephalians, each adapted. Despite the abundance of predators, one relative silver lining of the late Permian was the lack of danger from above. Unlike the later Mesozoic, which saw skies filled with flying reptiles and birds, the late Permian had no serious aerial threats. The largest flying creatures were griffinflies and other ancient insect-like forms from the order Paleodictyoptera, some with wingspans over 2 feet. Impressive in size, yes, but harmless to larger animals. And not especially diverse or common due to the earlier Carboniferous rainforest collapse. There were also Weigeltosaurids, small gliding reptiles that resembled flying squirrels or bats. Though fascinating, these creatures posed no threat to vertebrates. They were primarily insectivores and spent most of their time in trees, having evolved well-developed features for arboreal gliding. But if there was one final threat to life in the late Permian, more devastating than any predator, it was nature itself. You may have noticed that most surviving species were concentrated in a few specific regions. namely European Russia and southern Africa. That's because much of Pangaea was simply uninhabitable. Global temperatures during this time are estimated to have averaged around 35 degrees Celsius, 95 degrees Fahrenheit, roughly twice as hot as today. This intense heat created massive deserts near the equator, where life was nearly non-existent. To the north, the central Pangaean Mountains spanned the width of the supercontinent, creating massive rain shadows and extended drought zones. In today's world, such climate conditions would trigger ecological collapse, and yet, in the late Permian, this was considered the normal state of affairs. Incredibly, things were about to get even worse. Around 252 million years ago, Earth entered an extinction event so catastrophic, it's known as the Great Dying, the worst mass extinction in Earth's history. This apocalyptic period is widely believed to have been triggered by the formation of the Siberian Traps, one of the largest volcanic events in geologic history. The resulting eruptions produced lava flows over a kilometer, 0.6 miles in length, thick and released unimaginable volumes of carbon dioxide and sulfur dioxide into the atmosphere. This greenhouse gas overload caused global temperatures to soar even higher. In some regions, the average yearly temperature may have matched the peak summer temperatures of Death Valley. And even if you could withstand the heat, you still wouldn't survive for long. The atmosphere became increasingly toxic due to a sharp drop in oxygen and a rise in noxious gases, leading to widespread hypoxia. To make matters worse, some research suggests these volcanic gases may have severely damaged Earth's ozone layer, resulting in ultraviolet radiation levels increasing by over 5,000% in certain areas. By the end of this extinction event, Earth was forever changed. An estimated 57% of all biological families and 83% of all genera had gone extinct. For comparison, the more famous dinosaur-ending KT extinction wiped out around 17% of biological families. Even though conditions on land were nightmarish, the oceans actually fared worse. Rising sea temperatures and ocean acidification devastated marine life. While dipping into the sea during this time wouldn't have saved you, it might have felt oddly soothing. Sea temperatures may have reached those of a modern jacuzzi. So, if you were a time traveler visiting the late Permian, your safest bet, surprisingly, would have been the ocean. Everywhere else, pure, unrelenting chaos. Thanks for watching, and until next time, stay out of the late Permi.